Oh, well, hello, and welcome to my review session for our test on Monday. This unit was on fresh water, and we learned a lot of things about wetlands and stuff like that. It applies to just North Georgia, but the main idea was really fresh water. So I want to take a few minutes of your time and just go over this real quickly so that we all get 100% on our test coming up. Now, you have 30 questions, okay, multiple choice. That's the thrust of it. There is for the advanced class, there is a written piece afterwards. We've already went over what that question really is, just to kind of demonstrate what you know and kind of get used to explaining yourself and writing things out as you would in an AP class or whatnot. So first of all, this was fresh water. And when we talk about fresh water, let's see if I can get over that. Come on. Oops. Okay. Hold on. There we go. When we talk about, first of all, what is fresh water? Well, most of the Earth's water is by far salt water. So that's been 97%, depending on your textbook, but for the most part, it makes sense. 70% of the planet's covered with water. Or covered with oceans, and most of those oceans are miles deep, so it just makes sense that most of our water is probably salt water. 3% or so is fresh water, and of that fresh water, most of that is locked up in ice caps or it's underground. So it's not something we see on the surface. Now that makes sense. If you look around you, mostly what you see is land, and then there is water probably under that land. So it does make sense that our water there'd be more groundwater than there would be surface water in lakes and stuff. We started with the water cycle, however, and we kind of added to the water cycle from what you had like in fourth grade. We could actually, as you could see, get really incredibly complex if we wanted to. However, when you get to AP Environmental Science, there is some, we do revisit this, and so I want to make sure that we have the terms down. That's there. For the most part, the main three, though, are evaporation, condensation, and precipitation. And so we have our evaporation right here. Usually that's where it all starts with the sun, obviously, and evaporation. Condensation is basically coming into a cloud, and then our precipitation, there's many types of precipitation when it comes back down. However, we've added to a few things too. The water cycle is a lot more than that, especially when you get to the point where it's measurable. Part of that was in this word right here. It says evapotranspiration, but what comes off of plants? Transpiration is the word we're going to use for this test. Evapotranspiration is just a little bit different, but it's for the most part the same thing. Transpiration, about 10% of the moisture in the air comes from transpiration, or it's estimated anyway. That came from plants. The roots take the water up, and the water goes out the plant's leaves and whatnot. So that's a slightly different take than just evaporation. There's more to evaporation than just lakes and rivers giving up water. What also is different, we talked about sublimation. This is a little bit more like in alpine areas where it's very dry and higher altitude, going straight from a solid right to a gas. We saw that with dry ice, right? And then finally, we added a little more to the water coming down. We talked a little bit about runoff, okay, water running off the surface. Okay, we've seen that. But what we may not know is infiltration is the term that's usually given to water moving underground, especially as it's going down and seeping in. Usually the more permeable the material, the faster it's going to go. If you look here in North Georgia, after these rains, the water just kind of sits around because we have a lot of clay. But as you see, infiltration is the actual movement down into the underground, into the aquifers, right, where the water is stored. We don't have a lot of those in North Georgia, but most of the world gets their water from aquifers underground. So that's our water cycle in a nutshell. We don't have to know volcanic steam and whatnot, but we do want to make sure we understand sublimation, what it is, and what runoff is, what infiltration is, condensation is, and whatnot. This is in your study guide. If you want to take a look at it there, it's on the Gim Kit. It's in a number of different places. I feel very confident of what you know here, looking at the formative check, that most of you just kind of get that. What we may not be as used to is the what underground. Now, most of us, we might remember the beaker that we put sand in. We tried to add water and had a saturated zone and unsaturated zone in the water table. I love this diagram here. They move me there right here so that we can take a look at it. I like how it kind of shows how the water table is really not a flat. Not usually doesn't come off as a flat line where there's water and not water. But for the most part, it does bend and yield. And our surface water, like lakes, rivers, and streams, is oftentimes the actual water table itself being exposed. And so when we go out to Narnia and we look at those rivers, like I've constantly been telling you, these are generally sourced from underground. That's where the water just kind of seeps in and as it develops, it builds and eventually discharges into Bentley Creek over here. But there we have a great view of our saturated zone, the water table, and the unsaturated zone. One question that kind of tricks students oftentimes is, well, what is lower, the saturated zone or the unsaturated zone? And while a lot of students, if they've memorized this, they freak out. We don't really teach it like that, but if they just think it through, the saturated zone has to kind of be at the bottom. That's where all the water goes. Obviously, if it rains a lot, what's going to happen to the water table? Well, let's think about what happens to the saturated zone if it rains a lot. The saturated zone is going to swell, and the water table is going to go up. If it doesn't rain for a long time, or if lots of people are using wells and drinking the water, or there's a lot of agricultural uses that can also do this as well, the water table starts to go down. And let's see if we move to the next one real quick. Boom. The surface water. What about our surface water? Well, this is a great view of a watershed coming right at you, right? We took our picture in front of our little mini watershed here in Vickery Creek. For the most part, the watershed is usually named after where it drains. I don't know where this drains. We could name it. We named it after various members of our classroom. But nonetheless, we have little tributaries that are contributing water to the main river here. And that's one word that we remember is tributary. Divide is the high points, okay, where the water actually, it's like a bathtub. The very rim of the bathtub would be like your divide. So that means there's probably a watershed over here that has a name as well. And then we have our main river here, and then the mouth of our river right there. You can also see that there's some representation for groundwater. The groundwater also flows down into this river. But that's the main parts of our surface water. When we get into natural resources, we'll talk more about pollution and point pollution and non-point pollution. And this really is where we'll draw on this basic background that we have here. When you get into environmental science in high school, this also becomes an important piece of a connection from what we're talking about now to that. Finally, we ended with wetlands. Wetlands are an area where it's generally obviously wet. The water table is on the surface. Now, they're not 100% wet all the time, always. Some, like maybe Okefenokee Swamp might be. Some of the saltwater marshes off on the coast might be. But from time to time, they can dry out. And the best example, of course, is like right here off the Big Creek Greenway, where we can see that there's tons of marshes and what you could technically call swamps there that do dry up from time to time. But that's what a wetland is, and they're an important resource because they oftentimes help control flooding. They filter the ground. They make sure that or they filter the water before it goes into Big Creek, and they provide a habitat, obviously a unique habitat for a large variety of animals and plants. So it's quite a resource that we have winding around us here in the Vickery Creek area that we can draw from. And that's why I'm blessed having these streams and stuff back here that we can constantly go to and look at it and see what's going on. With that in mind, that is the end of what I have. That's the main piece of the test. It's 30 questions. It'll be on School City. We try to get that so it's immediate feedback. I think you'll do well. Our next unit is oceanography. We do meteorology after that, which is kind of like the water cycle revisited. And then we go into resources, natural resources, and we're done. You guys will be 7th graders. If you have any questions, feel free to make sure you shoot me a message on It's Learning or bring it up right before class. I don't think this test is going to be a long test. It's not going to take the entire class period for sure. With that in mind, have a good day and good